development platform which gives you low code APIs, which helps you move very fast. So for example, if someone wants to query blockchain data from a wallet, very easy to do that using Shyft APIs. We have bunch of APIs and SDK functions for that. If someone wants to deploy their own marketplace, they can do that very easily. And setting up a launchpad with Candy Machine, listening to on-chain events that are happening, and a bunch of different things can be done using Shyft APIs and SDK. So if we see, so these are all the APIs that we currently have for wallet, NFTs, semi-custodial wallet, fungible tokens, marketplace, NFT collections, relayers, transactions, and a bunch of things. So let's start with wallet, because that's the first thing that anyone connects to a dApp. So using Shyft APIs, you can very easily get balances, get token balances, get all the token balances. So if I fetch all the token balance of this particular wallet address, you can see I'll get the token address, the balance, associated account, and the metadata. You don't have to make another extra call to just get the metadata of this token. You'll get the name, symbol, and image like this. Similarly, in one API call, you can get the entire portfolio of a wallet. So you can see for this particular wallet, we are getting the sol balance, the number of tokens, address and balance of each tokens, number of NFTs, 66 NFTs, and the entire data of NFTs along with the on-chain data. And just getting the sol domain names is also possible. Just enter the wallet address and you'll get all the sol domains that this particular wallet holds, like crypto banter, this and this. And just getting any kind of information from a wallet is super easy, whether it be transaction history, domain names, balances, and all the NFTs as well. Like for NFTs, you can get all the NFTs of a particular wallet. So now the additional benefit is that normally fetching NFTs is very slow. Like if a particular wallet has like hundreds and thousands of NFTs, it's going to take a lot of time. But with Shyft, what we do is we cache the NFTs. So we have a caching layer. The first time you fetch, it might be a bit slow, but then it gets indexed in our database. And the next time you call, it's super fast. And we make sure that every time you get the latest on-chain data. So as you can see, there's a lot of NFTs here, and it just took 3 seconds. But if I call again, it will be even faster, 2 seconds. And it's not just on-chain data, it's on-chain and off-chain data. So you don't have to make another call to get the attributes like this. And if you notice the images, you have the additional image of the NFT and you have a cached image URI, which is basically the CDN link of the NFT image. So what we do is we store the image and then upload it into our caching layer, which is the CDN. So the end user experience becomes much better. And all of this happens automatically. You don't have to do anything at all. So let me just show you an example. Let's take a random NFT from Magic Eden, which we might not have passed as of yet. Let's say this one. Let's take this one, and I'll take the mint address, copy it. I'm gonna read the NFT here. So it will get me the on-chain, off-chain, all kind of data, and the owner details as well, like who's the owner. So you can see the image URI, cached image URI, they're both same because we have not cached the image yet. And you can get the owner details, mint, creators, attributes, all the details. And if we just give it a little bit of time and then we call again, you can see the image link automatically updates to cdn.shyft.to. So it's like just by reading NFTs through Shyft APIs and SDK, you automatically have a CDN and caching layer deployed for you without you having to deploy your own infrastructure at all. On top of that, so this is for reading, but we also have functions and APIs for minting NFTs and minting tokens. So as you can see, we have like, for example, create NFT v2. So what happens here is you provide it a bunch of data and it returns you. Let's actually try to mint an NFT here. So you specify the image. I'll just select a simple file. Let's say we will mint this one, and you set certain. We're minting on DevNet. So yeah, just name. Let's do Vietnam. Workshop, and symbol is SEN. Okay. Let's try to mint and see what happens. So what this API is doing here right now is it's creating metadata, uploading the metadata to IPFS for decentralized storage, then using the metadata to mint an NFT, and you get this encoded transaction. Now all we need to do is just sign this transaction, which we can do either programmatically, or we've created a small utility app here where you enter the transaction, you connect your wallet, and let's see, should be able to sign it. Yep, the transaction has been signed, and we can verify this on Translator. So Translator is another Solana explorer that we have created, which makes it very easy to understand what kind of transactions are happening. No? Okay. Let me just connect my wallet here, and we should be. Oh, because maybe it's on DevNet. That's why. Just a minute. Or if I connect DevNet, then I do this. No? Okay, wait. Let's just check if it's there in my wallet or not. Okay, there's a bunch of NFTs that will be difficult to find. Yeah, this is in the Explorer, and we can see that the transaction is successful, and this is the NFT that has been minted. And you can see this is the Super Team Vietnam workshop, which is minted as an NFT on DevNet, and it's in my wallet. So basically you can mint NFTs on demand. Now this is very useful for a lot of Web3 consumer apps and a lot of games as well. For example, you just, whenever someone finishes a quest in a game, you want to mint an NFT. You may want to give an achievement unlocked as an NFT. You may want to mint weapons or anything. Anything that you want to mint on demand, you can do that using these APIs. So there's a bunch of things. Similarly, you have minting APIs for tokens, and you have for marketplace as well. So just creating a marketplace, listing marketplace on it, and buying. It's very easy. Now the additional benefit of using, say, something like Metaplex over us is that if you're building on, say, a browser, on a mobile application, you have to write code separately. But with this, you don't have to, because there's one backend that is deployed for you, which generates transaction and returns to you. So you can then create a minting transaction on a mobile or a browser in the same way. And for marketplace, say you can use auction house protocol as well. But the additional benefit here is that any data, any transaction that happens on your marketplace automatically gets indexed. So you don't have to deploy your own infrastructure backend database to figure out, say, something like you want to get active listings of last week sorted by price. It's just very easily doable here. So you can get active listings, you can filter active listings, you can get what are your current sellers, you can get the order history, you can get your stats of the marketplace. So it's like a managed service over auction house, and it's very easy to do that. So similarly, we have a bunch of things. Let me just actually walk you through Translator. So this was our submission to Grizzlython, and what we did here is we created a very simple to read, a human-friendly Solana Explorer. So first of all, you can search any sol domain name. You enter any sol domain name and you'll get all the NFT collections. This wallet holds all the tokens. This wallet holds what's the balance and all the activity, live activity that is happening on this wallet. And you can see that for the transactions that we pass, it is very easy to understand what kind of transaction this is. Like this is an NFT mint. This NFT was minted. It was minted to this user ID, and this was the sol transfers that happened. NFT mint, and you can just keep on scrolling. The transactions will keep on loading automatically, like this. A token was minted, so it's much more human readable, and all this is powered by Shyft APIs. Now another thing I want to show, like how do we do this, is if you see a particular transaction, there's two kind of formats here. One is the Shyft transaction, other is the raw transaction which Solana gives. Now this raw transaction is very difficult to understand, but what we do is we transform it, we decode it, and we reverse engineer, and we identify what are the actions that happen in this transaction. So for example, this is an NFT mint transaction, and NFT mint happened, and you get the relevant information for it, like what is the NFT address that got minted, who's the owner, and how many got minted. Similarly, for sol transfer, you get who's the sender, who's the receiver, and what is the amount. So this is a custom transaction format that we have created so that it is easier for anyone to understand what is happening on chain. Now we combine these kind of transactions with callbacks, and callbacks helps you monitor on-chain activity. So for example, you can start a callback and say you want to know whenever there is an NFT listing or an NFT sale happening on Magic Eden, and you'll get to know that instantly because we are able to parse different kind of transactions. So yes, just wanted to introduce you to this one. And yeah, so it's not all talk and boring. I'm actually gonna walk you through a particular use case of what can be built using Shyft. So we'll be using Supabase and Shyft APIs, Shyft SDK for this. So now I'm not sure if you know about Supabase, but Supabase is like a Firebase alternative. So what it does, it makes it you sign up and it deploys a database for you. You can write serverless functions, and you have a REST API, very easy to use SDK to query your database. So it becomes very easy to start off, and I've created a small project here, which is an activity feed. So what we're going to do here is, I'm going to ask all of you to give me your, wallet addresses just on DevNet. Any fake wallet addresses will do. And what we'll do is we'll create an activity feed. Say something similar to Instagram. On Instagram, you're connected with your friends, and anytime any of your friend updates something, you're able to see it in a feed. Now similarly here, what we'll do is we'll get all the wallets and we'll create an activity feed out of it. Now whenever any activity happens on any of our wallets, so for example, someone, person A sends some NFT to person B, you're able to see it. So it becomes like a friend feed, a friend activity feed, and you can build it in real time and very easily using Shyft SDK. So what I've done is I've created this is a database, and I've created just 3 tables here. One is the feed, activity, and accounts. And I've created a small project here on Express where we're going to listen to real-time activity happening on our on different wallets, and then update it in our database and then read it. So let me just quickly start off with, yeah. So yeah, so we have this SDK. Where did it go now? Yeah, we have Shyft SDK. Makes it very easy to make function calls, because calling a function is like 10 times easier than calling an API. And the SDK supports wallet, NFTs, token. All of these functionalities are possible using our SDK. So now what we're gonna do, I've already installed I've already done npm install, but all you need to do is again here, just I'm gonna stop this and then npm install Shyft to JS. And the package is here. Now all we need to do is you need to get an API key first. So that's very easy. You just sign up on Shyft and and just log in and you'll get an API key here. So I already had the API key anyway, but just wanted to show you that you can get an API key here. Another thing, just if you click on run in Postman, the whole APIs will be forked in your Postman collection, so you can experiment very easily. So I've already set up an environment file where I have my Superbase, URLs, everything, and have the test API key. And so we initialize the Shyft SDK with the API key and the network. The network is mainnet, and a client gets created. Now using this client, it has different modules: callbacks, candy machine, marketplace, NFT. You click on NFT, you can burn NFTs, burn many. You can create from metadata, get NFT by mint, owner, get owners, transfer, bunch of things you can do. And now, this is just dummy code. What I'm doing here, I've put in a wallet address and I'm getting the balance, the portfolio, all the tokens, and just rendering one NFT, all the domain names. So if I start here, okay, here's the problem. I was just working on this before. We create, repeat. Yeah. So as you can see, it's all just console logs. I'm sorry, I don't have the UI for it. Yeah. So you can see you get the entire portfolio. What's my sol balance? How many tokens I have? The address, balance of each token, how many NFTs I have, and NFTs. This is from Get Portfolio. This is my entire portfolio and the metadata of NFTs. Now what we are doing here, if you see before here, you're only getting the token address, not the metadata, because eventually you would want to, render the token as well to get the image of the token or to get the symbol of the token. So you can make extra calls, but there's another function, get all the tokens. Yep, get all token balance, which will return you all the tokens that you have, along with the metadata, which is the name, symbol, and the image. So it becomes very easy for you. And getting balance also is very simple. You don't have to deal with associated token accounts, all those kind of things. And you're seeing that the balance is already normalized based on the decimals of the token. So it is not 30000 because this is USDC, which has like 6 decimals. So everything is already normalized and very, very simple. Similarly, we read one NFT, just to showcase, and you can see that you're getting the name, image, cached image URL, which is from CDN. You're getting the owner of the NFT, attributes, option attributes, everything basically. And you can see that these are just the domain names. Yeah, you're getting all the domain name, this wallet also. So I think someone has shared me their wallet. Let's just try and fetch information from this wallet. Balance, portfolio, all the tokens, domain names if any. Okay, I'm fetching domain names twice, sorry. Yep, let's see. Okay, so yeah. Okay, so right now it's only 0 because I'm guessing it's just devnet, sol balance 0, portfolio, all the tokens. This domain name is from a different wallet, that's why. So essentially just, querying, because wallet is the first thing that anyone connects and everyone wants to query data from inside a wallet. It becomes very easy. Querying transactions, past transactions. Now, for example, if in this wallet we fetch transactions, we'll be able to see that, okay, this user has been minting this NFT on this protocol, doing this kind of swap on this protocol. So it becomes very easy to understand blockchain data. Okay. Now the next thing we're gonna do is, so this is just simple Nest, Express.js stuff where I'm creating feeds and I'm doing a bunch of things. So now let's go to my work. Let's go to localhost now, and we get feeds. So this will get us all the current feeds. We don't have any current feed. So now imagine someone wants to watch wallet activity of influencers or whales. So you enter a bunch of say 20 influencers, and whatever activity those 20 influencers are doing, you will be able to see that in a feed. Now, how good the UI is being created, that is dependent on whoever is creating. Similarly, like there could be a feed of Super Team Vietnam. So whatever Super Team members are doing on chain, then everyone will be able to see that in a feed. So this is like a very nice idea. And if you guys would be willing to share your wallet addresses, just create new empty wallet addresses and we'll do some testing here, and then we'll be able to see a feed in real time. So that would be really helpful. Meanwhile, these are 3 dummy addresses, wallet addresses that I have. One more, and yep, is anyone sharing? No one.
I think we got 2 in the chat.
Yep. So we'll end this one. Okay. We'll just see if someone else shares, because I didn't add an edit functionality yet. And we'll just see if there's some random, let's pick some random wallet addresses from on-chain. Let's go to translator. Let's go to Jupiter protocol, which is very high transaction protocol. Just a minute. Okay, this is the TensorSwap protocol. So essentially, you can just enter any protocol address and you'll be able to see the live activity that is happening on that protocol. So someone just sold this NFT. Okay. Oh, these are failed transactions. Okay. A lot of failed transactions. So this tells the status. Sold by this to this. Okay. Let's take this wallet address. A minute ago. Okay. Let's see. Okay, if anyone else wants to share, otherwise I'll create a activity feed here now. I'll name it Vietnam feed. No one? Alright. So let's see. We'll create a feed here. Feed created. Let's see. And yep, we got some logs which tells us that now a lot of things happened here. One, a feed entry was created in our Superbase database. On top of that, callbacks were initialized on all the wallet addresses. So if we see here, so you can see an entry is created. Feed, the name, and this is the callback ID. I'll explain what this is. And then we have the accounts here. So these are the wallet addresses that I've added and they belong to this feed ID. and this is an activity table. So whenever a wallet does some activity, it will come here. Now, so this callback ID is because if you want to remove or stop a callback, you need this callback ID. That's why we save it here. So what we're doing here is essentially, we come here, we create the feed accounts, we add it into a database, and then whenever this is added, we start callback. Starting a callback registering is very simple. You just get the Shyft client callback.register, you specify the account addresses, and you specify the callback URLs, and it's done. Now, one thing I'm using the callback URL is here is this. This is the webhook.site. This is my bad. This way, we will not be able to save it in a database. So what we'll do is we'll create a local tunnel. Okay, we got another wallet address. We'll create new one. So what we'll do here is we'll create a local tunnel basically to expose our local host to internet. We're using Servio for this, and all we need to do is come here. We basically routing our SSH, doing an SSH of our local host to Servio.net, and now, okay, so this is the callback address that we've received. So now let's create another one, accounts, and let me just update the callback URL to this. And I need to start another one now. Okay, everything's fine. Now what we're gonna do is we're gonna create a feed. Let's clear the previous one. Delete this. I'm gonna delete all the activity, and then we'll start fresh. Okay. So now come here. I'll add the new wallet address that I've gotten. Okay. So we have 1, 2, 3, 4, 5, 6, 7 wallet addresses. Okay. Now whenever there's any activity happening on 7 addresses, our database should automatically update. Now this also becomes like a caching layer of Web3, which is like you have a local copy of on-chain data, and anytime the on-chain data changes, your local cache updates. So you don't have to query the on-chain data all the time. You can just query your database, which is super faster. Now imagine if any one of you have built your own protocols, so doing a get program account calls is very slow, very slow. So now imagine your protocol is doing transactions, and every time it does a transaction, you get notified, you create a local cache out of it in your database, and you just have to query your Postgres database. You don't have to do a get program account calls anytime. We're actually creating a small open source code snippet for this thing. So let's create a new feed. Let's check our Superbase tables. Yep, all the accounts are added. A feed is created, but there's no activity right now. So what we're gonna do is the feed entry added. Done. Index.js, yeah. So essentially just register a callback. It will give you a callback ID, and then we are again updating our database with the callback ID because we might need to stop it later. Now what's going to happen here is we've registered this as the callback ID. So now this local host is now here. So if I go here and I go here, hi Super Team Vietnam, we're building an activity feed. So this is running in my local host, but I'm tunneling it to here, which is this like internet. Because to receive webhooks from Shyft's backend server, you need it can't send webhooks to our local host, right? It needs to send to some internet connection. So that's why this is required. So now let's do one thing, guys. Let's do some activity on DevNet. Wait. DevNet. I hope this is DevNet. Wait. Okay. Yeah, this is DevNet. So now let me just transfer some kind of sol, some on DevNet, of course. There's Super Saiyan, there's standard tokens. I'll just send it to to one of the, okay, say this account address, and let's see what happens. We should get a callback. Done. Okay, you can see the HTTPS request was sent, and
So easy.
feed entry added. Okay, let's see if things happened or not. Because what we are doing here is we are doing activity create, and anytime the activity is created, we are again updating our database. No, okay. Must be some issue. Let me just check. Callback received. We didn't get a callback received log, which we should have. Let me just check the callback that was created in our database terminal. Just seeing the, okay, the callback URL is correct. Event folio. Interesting. Okay. This is still running. Okay. I'll just try again. But I added this wallet, right? This one. With this one. And video. Okay. What is happening here? Okay, wait. Must be some issue. Let's just test on Webhook. This one. Let's create a new one. Copy this. I'll update the callback URL to this. So whenever you're creating a callback, you need to mention a callback URL, the account addresses, and some events that you're interested in. If you don't mention any event, then it basically tracks down all the events that are happening. And yeah, I've just updated here. Now let me see. I'll just transfer this. Yep, you can see instantly we got the callback, token transfer. And you only get the relevant information. If you want, you can get the entire raw transaction as well. But here you're getting just the relevant information, which is the type of the transaction is token transfer, the amount was 10, this is the receiver, this is the sender, this is the token address that was sent, this protocol was involved, and the latest account data. So using this, you can build a bunch of things. And then using different APIs, you can get token info, this address, and stuff like that. But actually, this was actually working. I'm not sure why this stopped working. Let's start again. Okay. Okay. And now this is also working. Now, okay. Activity, create, callback received. We're doing activity create, on activity create, we're doing this, but while hitting activity create. Yep, okay, got it. My bad. the callback URL needs to be activity create, not just this. Yeah. So now, let's see. Now I think it should work. Let's try it out. Let's try it. Let's do this. 10, next, send. With this one didn't get. Yep, done. So now you see feed entry at, oh, no, let me just, which one is this? Yeah. Yeah, now you can see our activity data is being automatically populated. So, if any of the wallet addresses that are that do any activity, it automatically gets here. Now let me just send you some DevNet tokens to the wallet addresses that are shared, and the activity is gonna come here. So then some solve. Okay, the first one, this one, I'm gonna send you 0.5. The callback received, feed entry added, and our database should be updated. Yep, another entry is added. So now, as people are doing activity on chain, a local, not a local, but a database cache is being created out of it. And then in front end, you can query it. And if you see, this basically just create account and then the entire JSON data. If we see what is the JSON data, yep, it has who's the signers, what are the signatures, which protocols are involved, and what actions happened what kind of transaction was this? This was a sol transfer, and then what actions happened? Only sol transfer happened, and you get this, and you get the account data as well if required. And like I sent 0.5 sol to this receiver, 0.5, yeah, similarly, and so for example, this I think if Tuan sends some DevNet sol to say Leo, it will automatically come here. Do you guys want to try it out? Or even I can just try it out, or you can just send. Let's try sending some NFTs. Okay, let's some random NFTs to, let's send this to Tuan. Yep. And now again a callback is received and entry has been added. And we can see entry has been added here. So this is a great example of different kind of products that can be added. Now you can also create notifications based on that. So for example, whenever if someone is working on a wallet application, anytime there's an incoming, outgoing transaction happening on that wallet, you can send notifications to mobile wallets or say to email addresses as well. If someone wants to create a data cache so for example, someone launches an NFT collection and they have like 10,000 NFTs. Now they want to know who are the current holders of their 10,000 NFTs. So what they'll do is they'll create callbacks on all 10,000 of their NFT addresses. And anytime an NFT address is transferred from one address to another, the owner detail will automatically update in their database. If NFT is burned, it will automatically get updated. If it is listed, it is sold, whatever happens, all the activity can be locally tracked and stored in a database, and then you query it, and then it's extremely fast, and you can do a lot of queries. For example, you want to know that how many NFT mints have been done in past 1 week. You want to know how many NFT sales have happened in my NFT collection in last 1 week. You are able to do that because you can listen to on-chain data, save it, and then do database queries on top of that. One use case that we ourselves using for this is candy machines. So what we do is people can start indexing their own candy machines. So you you create an index of your candy machine, and anytime there is a mint happening on your candy machine, we keep on listening to all the mints that are happening on your candy machine, and we keep on saving it internally. So you can, at any time, you can get all the NFT addresses of your candy machines. Version, okay. This is old one. I need to specify the version. No, sorry, this is not even a candy machine. My bad. But yeah. So this is like one example that we used ourselves. And then, yeah, here, sorry, it was in monitor. So start candy machine monitor. You start the candy machine monitor, and we keep on monitoring your the on-chain activity of your candy machine. Anytime something happens, we save it. So basically, using this, you can create a lot of event-driven systems. And combining this with the rest of our APIs, which is NFT, minting NFTs, burning NFTs, bulk burning or bulk transfer of NFTs, marketplace, anytime an activity happening on your marketplace, you query it, you save it, a lot of things are possible. So, yep, I guess this was the demo that I wanted to give. And this is the SDK. This one is the SDK. I'll just start sharing some links here. SDK, and documentation. This is the documentation, and we also have created a lot of blogs. So, how to get owners of NFT owners on Solana, how to create an activity feed, how to get decoded Solana transaction, wallet data, a lot of specific developer guides. Say someone wants to create loyalty reward system for e-commerce, how can they do that? NFT marketplace, membership NFTs, Web3 game development, airdrop campaigns, candy machine launch pads. So we keep on creating a lot of blogs on how to do XYZ using Shyft, SDK,
Hello?
and APIs.
Hello.
And
Đăng, anh đang học.
I think, yeah, that's pretty much it. And this is the Shyft website. You get the Shyft API key and you start hacking. There you go. So we have a bunch of ideas that you guys can follow to create a lot of things like this. So one is real-time database cache, which is like Firebase for crypto, because Firebase is like anything happens on chain, the database keeps on updating, and you query it very fast. Then portfolio pages and Solana explorers, on-demand minting, Web3 games, in notification systems. A lot of things can be built using our SDK. And the best thing is, I would suggest trying out the SDK itself rather than the API, because I feel calling a function is like 10 times easier than calling an API. You don't have to worry about the response structure. It's already there. So for example, get all token balance, it returns you a token balance, which has the address, balance, associated account, and token metadata. Token metadata is this. So it's like, it becomes very easy for you to deal with a lot of things compared with, say, having to directly deal with RPCs. So this is much, much simpler. And if you check out the different things that Shyft client can do is a candy machine. Create a candy machine, mint from candy machine, monitor, read mints, read NFTs, a lot of things. Then marketplace is definitely very, very easy. So you just create a marketplace, pass in the parameters, an on-chain marketplace is created for you. Of course, now we have read APIs and write APIs. The difference is that for write APIs, you will get an encoded transaction, which I showed here. Say, for example, this. So you get the extra information, but you get the encoded transaction. This transaction is only recorded on blockchain once this is signed. And for that also, we have a lot of functions in our Shyft client. So it's transaction dot, no, this is just to get transaction data, but this wallet. Okay. No. Okay. I'm forgetting where how do we sign? Okay, sorry, my bad. It's not here, but it's here in signer. So you have functions like sign and send transaction with private keys if you want to store the private keys in your database in some environment variable, or sign and send transaction, partial sign. So you can sign the transaction through here also, or we have this which I used to sign. This is just a handy tool. Sign. Sharing it here. In case, yeah. And yeah, I think almost done. Let's see if anyone has any questions, any doubts, anyone want to discuss anything.
Can you show me how to do pagination on the query? Because, for example, for NFT, we have a lot of different things.
Yeah. Yep. You have burn many, create, get NFT by mint, get NFT by owner, get owners of an NFT. So you can specify 10 NFTs and you'll get all the 10 NFT owners. So if I show you here, we get owners. So yeah, I enter these 10, these 3 NFTs. You can enter 10 and you'll get the NFT address, the owner, like this. So using this, NFT collections can create snapshots of their holders. Yep. So sorry, what was the question?
So my question is that how can I do things like pagination or filter on your query?
Yep, very easy. We already have that. So you call read wallet NFTs and it's already paginated. There's total count, page, size, total pages. So using this information, you can very easily paginate. So you can specify the page number, what's the size, how many NFTs do you want in one size, what is the page number that you want. So if I specify 1 and I'm just specifying 1, so that's why I only get 1 NFT. If I do 10, so sorry, here, yeah, we can do page 1 and then size 10, and similarly you get 10 NFTs in one page.
Yeah.
Page 1 size 10, total pages 18, total count 172. If I set size to 1, you'll get only 1 NFT. So it's already there.
Yeah. What about filter? For example, I see that some query have a lot of information. For example, let's talk about the feed. Can I filter some information on the feed instead of like getting everything?
Yeah, definitely. So while creating a callback, you can specify what kind of event do you want to listen to. So if you go to our documentation, I keep getting lost here. Callbacks. Here. So these are all the event types that we currently support: NFT bid, burn, list, cancel. And when creating a callback, you can specify what kind of events you are interested in, like this. NFT list sale. If you don't specify an event, it will listen to everything. But this way you can filter out certain events. This is one. Then another is filtering on callbacks. Then on read all NFTs, you can specify update authority. So you maybe from a wallet has maybe 500 NFTs, but you don't want all the 500 NFTs. You only want NFTs of your own project, only of your game. So what you can do is you just set update authority and you'll specify your own update authority. So for example, if you try here, let's take this update authority. I'm not sure if this is the correct one, but yeah, let's see. So yeah, I only got one NFT which had this update authority. If I remove the update authority, I'll get all the NFTs this way.
Yeah. Yeah, yes, that's really good.
Yeah. We have another thing which is search, but it's only once we have cached the data. After that, you can do a lot of things. You can actually filter based on attributes also. So here, for example, you only want those NFTs who has an attribute edification and which has greater than 10 and energy, and whose royalty is less than 5. So let me see, and whose creators are this. So you can do all of these things, which is none right now. If we do this, yeah, and if we do royalty, yeah. So, but this can also be done, but only once we have cached, indexed the wallet's NFTs. Otherwise, it's not possible to filter. Yeah.
Yeah. Okay. What about PDA? For example, I have a program and I want to get update from some PDA from a program. Given that I know how they construct the seed, is it possible for me to do that through Shyft API?
Yeah, absolutely. So while creating a callback, like we're doing here, while registering the callback, you specify your PDA account address, and whenever there's a transaction on that PDA address, you'll get an update, and you'll get the data of the PDA address as well. So you don't have to make another get account info call. You'll automatically get it. So there's actually one game, Kyogen Clash, which is using this functionality to create a to continuously keep on updating their state, because it's a fully on-chain game and they have a lot of PDS which keeps on changing.
Yeah, thank you. So I think basically Shyft replaced all of my server. I think I don't have to deploy any server anymore because I I already have a call back here.
It depends. It depends on your use case. A lot of use cases are already covered, but because that's the whole point. If you see currently, people are just reinventing the wheel. They are doing same thing again and again. Everyone is doing that. But you don't need to. With the APIs, let the infrastructure providers handle that, and then you focus only on what is relevant for your product. So you deploy backend infrastructure which helps your product. Yep. Any other questions? Any other doubts? Anyone wants to discuss anything? No? Okay. So I think that's it then. I'll share a list of ideas as well, that we in writing, and then please get your free API keys. We have a very generous limit, and we see. So in a free plan you get 500,000 credits, which is equivalent to almost 5,000 API calls. And we have like special offers for you guys for Super Team Vietnam. If you want, reach out to us and we'll be happy to help you guys with better plans. And yeah, I mean, let's build cool things.
Yeah. Thank you very much. Your API is really helpful.
Thank you. Yeah. Okay. All right. I think that's about it then.
Yeah. Thank you very much for the workshop, and we hope that we can work with you in the future in many new projects from Super Team. Thank you very much.
Yeah. Definitely. All right. All right. Thanks everyone. Thanks for joining. Really nice. All right. Bye everyone.
Bye bye.